Welcome to Demystifying Math. In this lesson, we're going to be solving a problem using matrices and Gaussian elimination. Suppose that a company has $300,000 available to increase their advertising expenses. The expected return for this particular company on advertising on television is 8%. They have an expected return of advertising on radio of 5%, and their expected return for internet ads is 4%. The company would like to get a return on their investment of $20,000. In order to reach a broad audience, the company has decided to spend twice as much on radio advertising as on internet ads. We want to find out how much the company should spend on the three different types of advertising. So we're going to set up a system of equations to represent the situation. So first of all, we're going to let x equal the amount spent on television ads, y is going to equal the amount spent on the radio advertising, and z is the amount spent on the internet ads. For our first equation, we have the amount spent on each of the items totaling $300,000. For our second equation, we have the return on those dollars. 8% on television ads, 5% on radio ads, and 4% on the internet ads, totaling $20,000 in return. Then for our third equation, we have the relationship between radio and internet advertising. They want to spend twice as much on the radio advertising as on internet advertising. So we get the equation 2z equals y. The next thing that we're going to do is try to turn this into a matrix. So the only adjustment I need to make is the last equation. Notice that I brought the y over to the other side, setting the equation equal to 0. That's going to help us to fill in the information into a matrix. So remember, with a matrix, all you're doing is using the coefficients of the variables for the first three columns, and for the last column we have the constants. So for x plus y plus z equals 300,000, we're just going to write in 300,000. And we're doing that for the second equation as well, our coefficients in the first three columns, and our constant in the last column. For the third equation, there was no x term, so we're going to put 0 as this coefficient of x in the first column. And notice that we also have a 0 as our constant. So now we have a matrix, and this is called an augmented matrix. Now, what we're going to use for this is Gaussian elimination. With Gaussian elimination, we can exchange any rows. We can multiply any row by a non-zero constant. Of course, if you multiplied it by 0, it would turn out to be 0. We cancel out, it wouldn't help us solve at all. But you can multiply it by any number other than 0. You can add a multiple of one row to a multiple of another row. So that multiple could be multiplying it by 1 if you choose to, or -1. Sometimes we need to get rid of some of the negatives. But you can multiply them by any number. And then you can add them or subtract them. What we're going to do in this video is rewrite the matrix in what we call reduced row echelon form. And that happens when we have eliminated all but one variable in each row. And we have a diagonal set of 1s in the first three columns. So for the first row, you want to have a 1 where your x value would be. For the second row, you want to have a 1 where your y value would be. And for your third row, you want to have a 1 where your z value will be. In the last column, you're going to have the solution for the variable that was remaining in that particular row. Okay, so let's start working this matrix. The first thing that I noticed was that I had some decimals and I want to get rid of them. So I'm going to multiply the second row by 100 to eliminate the decimals. Now, the next thing that I want to do is start eliminating some of the variables. So I'm going to multiply row 1 by 8 and add that to the negative of row 2. Then I'm going to put that answer in row 2. And what that's going to do is eliminate the x value in row 2. So multiplying the first row by 8 we get 888 and 2,400,000. Adding that to the negative of row 2, we get 034 and 400,000. Now we're going to put that answer back into row 2. So I have a new matrix that I'm now working with. Okay, so the next thing that we want to do is take row 2 and add it to 3 times row 3. This will help us eliminate another variable. So let's go ahead and do that. So we're taking row 2 as it is, and then we're taking row 3 and multiplying it by 3, which gives us 0, negative 3, 6, and 0. Then we're going to add those two together, and we get 0, 0, 10, and 400,000. And we're going to put that answer back into row 3. Remember, when you're working with row echelon form, you want to have ones on a diagonal for the first 3 columns. And we've got that diagonal going, we just don't have them all as ones. So let's keep working our matrix and see how we can get there. So the next thing that we're going to do, just to simplify our matrix a little bit, is multiply row 3 by 1/10, or divide it by 10. So that actually ended up solving for z for us. But we could use back substitution, but since in this video we're just going to work on the row echelon form a little bit, we're going to keep working the matrix. Okay, so we're going to take row 2 and multiply it by negative 4 times row 3. I'm sorry. We're going to take row 2 and add it to negative 4 times row 3. Okay, so row 2, taking it as it is, and then negative 4 times row 3 is 0, 0, negative 4, negative 160,000. Adding those two together, we get 0, 3, 0, 240,000. And we're going to put that result back into row 2. So now for row 2, we only have one variable left. So we could actually solve for y at this point, but we're going to keep working the matrix. Alright, so we're going to take row 1 and multiply it by negative 3 and add that to row 2. So multiplying the first row by negative 3, we get negative 3, negative 3, negative 3, negative 900,000. Adding that to row 2, we get negative 3, 0, negative 3, and negative 660,000. We're going to put that answer back into row 1. So now we've eliminated one of the variables in row 1. We need to eliminate another variable in row 1. So we're going to multiply row 3 by 3 and add it to row 1. So repeating row 1 and multiplying row 3 by 3, and then adding them together, we get negative 3, 0, 0, negative 540,000. So now we have only numbers on a diagonal, which is good, but we want those numbers to be ones. So we're going to take row 1 and multiply it by negative 1/3, and take row 2 and multiply it by positive 1/3, and we get the diagonals being ones. And that means that we can solve for x, y, and z at this point. So this row echelon reduction, it's just actually doing the back substitution for us without us having to rewrite the entire equations. Okay, so x has to be 180,000, y is 80,000, and z is 40,000. So now that we have solved for our matrix, we have actually solved for our system of equations. So let's go back and check and make sure that we did this correctly. So adding the 3 amounts together, we get 300,000, which is the investment that the company wants to spend in addition to the advertising they're already doing. Then the expected return on those investments comes out to be 20,000. And we have twice as much that we're spending on radio advertising as on internet advertising, so that's going to be correct as well. So we've checked all our work. So if the company spends an increased amount in advertising of television by 180, increases their radio advertising by 80, and their internet ads by 40, they can expect an additional return of $20,000 on their investment. All right, thank you for tuning in to Demystifying Math.